Good morning, good afternoon, good evening, and thank you for joining us. My name's Nishant, and I'll be your host for the session today. So here's what we'll be covering today. We'll do some quick introductions of both the panel as well as Digite, and then we'll move on to our topic for the day, reinventing project management through AI. We'll also try and ensure we have ample time for questions that you may have, and we'll take those at the end. The session is being recorded, right? So we'll send you a link in a day or two. And please feel free to ask us any questions at any time during the session. You'll notice a comments chat box on the GoToWebinar panel. Please use that for all questions. So our main speaker for the day is Ashwin Swarup. Ashwin heads the data science division here at Digite. We also have with us Mahesh Singh, co-founder and CMO at Digite. Mahesh also leads our consulting engagements in Europe and the Americas. So before we get started, a little bit about Digite. So we've been in the lean agile project management, application lifecycle management space for the better part of 2 decades now. We're headquartered in Cupertino, California. We have actually a lot more than 1 million users right now. Need to update that. Spread across the globe, right? The products that we have, namely Swift Enterprise, Swift Kanban, Swift Ease, been helping teams and enterprises with lean agile project management, value stream management, DevOps, and a variety of things. Right? These are actually some of our customers. We have teams of 10 members. We have enterprises with 100,000 users using our tools. In fact, I see some of you in our session today. So thanks for joining, and that's awesome of all of you. Right, so we're set. Before I hand it over to Ashwin, I do have a couple of questions. We noticed quite a few, when you'd answer these questions, right, when you were registering for the session. So we had some questions for you, and let me just get them up quickly, right? If I could request all of you to use your phone to scan the QR code, or, well, if it's more convenient for all of you, if you could just open a browser tab, go to slido.com and type in that 6-digit number. Just a couple of questions and we should be done. Let me just paste that here. Right. So our first question is, as a project program portfolio manager, right, we saw a lot of you register for this webinar today. Which of these tasks take up most of your time? And pick the top 3. Okay, that's less than 5% of you answering. We'd like to make this a little more interactive, so we'll give it some more time. Okay, let's move on to the next question. Right. So of the tasks you listed, which do you think will be automated by AI? And again, feel free to pick the top 3. Ashwin, I think you have your answers there.
Yeah, it's amazing to see a lot of the, it's amazing to see this live participation of and seeing the views of our audience. So this is really cool.
Okay, folks, last 5 seconds and we'll begin. Okay, thank you so much. So let's get started. Ashwin, over to you.
All right. Thank you very much. So from the polls, it's quite clear that status and reporting, tracking and monitoring, and planning and estimation seem to be these case scenarios um, which which have a opportunity for being automated using AI. So let's start with our today's topic: reinventing project management with AI. A bit about me. I am Ashwin Swarup. I'm the VP of Data Science and Data Engineering at Digitech. I lead the data science initiatives here in Digitech. So I love to game, and apart from my daily work, I also like to dabble in hydroponics during the weekend. I speak quite frequently in AI conferences, and I've blogged as well, mostly around data science. I have around 12 years of experience in data science. I've worked across multiple domains, both in continuous manufacturing and discrete manufacturing. So grouping all of them into something called industrial IoT. And I've also worked with use cases which involve recommendation engines, revenue optimization, and my latest free is also in agricultural technology and conversational AI. So within Digite, my focus is on the AI products that we have. So we have a portfolio of AI products and augmenting our existing suite of application lifecycle management products with AI features. So this is my mandate within Digite. And my team at Digite focuses on various use cases. So currently they're working on recommendation engines, prediction engines. We have a large focus on explainable AI because we believe that when we are dealing with humans, it's very important to let AI clarify its performance and its the way it comes to certain conclusions. So that's an explainable AI, and we also do deep learning based image processing and natural language generation and processing. So that's a bit about me. So let us start with this large statement that Gartner made in this report last year. It says that 69% of the routine work that project managers or portfolio managers do will be fully automated by 2024. And that was a clarion call for us. And of course, then the first thing that we ask is, what is this routine work that they talk about, right? And we scan through various literature papers about the daily work that project managers or portfolio managers do, and we grouped these different tasks that they do into 8 large categories, and those are the categories that you have voted upon, right? And then within each of these categories, we identified case scenarios by which we can potentially get AI to automate these case scenarios. And we will be discussing those scenarios in the next half an hour or so. So how do we automate work for portfolio managers or project managers? The first, of course, which you guys overwhelmingly voted can be automated, is tracking and monitoring, right? And we do that using predictive visual alerts, which I will be covering. The next is status reporting, which you guys have also said can be automated. So that is second on our group of discussion, where we talk about how we can use scaled reporting so that we can. So there are two kinds of scaling that we talk about. That is transactional scaling and dimensional scaling. So I will come to it and discuss that in detail. The third thing is risk identification and assessment. Now, this is a case scenario based analysis kind of system where we're trying to figure out different kinds of case scenarios that are possible and how these projects will evolve under different case scenarios. And we, of course, talk about human in the loop here. And last but not the least, planning and estimation. And we talk about how AI can help in planning and estimation. We've not forgotten the other three, collaboration, strategy, and documentation. And collaboration is a very large component. So we will, because of the limited time that we have, we will be covering these 4 topics in this webinar, and the remaining 3 will be covered in our subsequent upcoming webinars as well. And there we will be covering collaboration, how we are using conversational AI for in situ problem solving for portfolio managers. We have a discussion on how AI can be used in strategy, what we call using AI to come up with optimum allocation of resources so that one can prioritize the strategy for a given organization. And it's also a feature of our upcoming product for portfolio management. And of course, we'll talk about documentation as well and how knowledge graphs can play a role there. All right. So starting on a journey for tracking and monitoring, here we wanted to ask you a question on KPIs, performance indicators. So it would be great if you could select all the KPIs that you use to track project health currently.
And for the folks who are just joining in, I've just added the survey link in the chat message. Just go to slido.com, type in the code and answer the questions.
So please choose the one which you depend on the most. So you can choose one. So it gives us an idea of what is one metric that people look at the most, right? We will give it another 2 minutes and then we can go on to the next question. So we see a lot of agile users looking at project burn down. That's really cool. And we have schedule as well. Oh, now they equally split. Wow. All right, there seems to be an equal split between schedule and project burn down. So let me move on to my next question. So the question is, when you are tracking this one KPI, which or these multiple KPIs in order to assess project health, the question is, as of today, how do you track these indicators? Do you track it intermittently as the project evolves? Do you do a continuous monitoring? That is, every day or every week with a regular cadence, are you continuously monitoring this KPI? Or do you choose to monitor after the project is over? That is, there are a lot of KPIs that you track after the project is completed, and then you look at the success parameters. Or do you do it a priori? That is, are you trying to predict what the KPI would be in the upcoming week, and then using that as a hint, take corrective actions? This is great. So we have a lot of people doing continuous monitoring of their KPI. Great. Continuous monitoring is a fairly large lead. Yeah, this is brilliant. All right. If everybody is continuously monitoring the KPI, but statistics say otherwise, that on average, large IT projects run 45% over budget, 7% over time, and they, while delivering, you deliver 56% less than what you had agreed upon earlier. And that seems to be a widespread thing across IT. Not very sure about how it is across other domains, but we have statistics for IT. So let's consider a case scenario, right? Tracking and monitoring. So in this, let's assume a case scenario, right? Let's say at 9 a.m. in the morning, the AI system is able to inform the project manager that 3 projects in the insurance vertical will face schedule delays in a week's time, right? So this is a priori before it even occurs, and that he needs to prioritize this vertical while addressing its problems over the other things that he has. So that means that so far, as we have seen, a lot of the crowd has voted for continuous monitoring, that a lot of people are doing continuous monitoring or in situ monitoring of these KPIs while the project is being conducted. But how would it be if we were able to predict how these KPIs would evolve over the coming weeks, right? And then suggest corrective actions, and not only for one KPI, but for multiple KPIs simultaneously. So though I had asked you guys to choose one KPI, often it happens that you look at execution parameters, they have some KPIs. You look at financial parameters, they have other KPIs. And all these KPIs need to be looked at in tandem, simultaneously. That determines project health. So we were thinking about how AI could help uh, predict KPIs 1 week in advance, or at least with some time horizon in advance, so that the portfolio manager has some bandwidth to recover if something is going wrong before it even happens. And that's where we came up with predictive visual alerts. So this is our thought process, right? Take care of your KPIs and projects shall take care of themselves. Meaning, if you look at all your KPIs and manage them well, chances are that the projects will do well. Now, how do we come to that conclusion? See, the thing is, the goals of project management in the future will not change, right? It will always be the same. They have to be completed within budget, within time, and provide a predetermined value agreed upon with the customer or the stakeholders. The only thing that will change in the future are execution methodologies. So at this juncture, it's agile. A majority of companies are going hybrid, right? So, and all these execution methodologies have some performance indicators. So whether it's burn down, whether it's schedule, cost, effort, all these are KPIs which you would use for different execution methodologies, whether they're qualitative or quantitative. And the moment these KPIs are quantitative in nature, we can start dealing with AI and predictions, because they're essentially time series in nature. So the key is to monitor these performance indicators simultaneously, and that too in a predictive fashion. That is, you're essentially looking at various parameters for project execution historically, and then from there trying to predict how these KPIs will evolve in the upcoming weeks. And so that if we are able to manage all these KPIs simultaneously and we're able to alert the project manager in time, chances are he has got enough headroom to bring the project back on track. And this is precisely what we have automated. So what you see here is essentially a visual way in which we are trying to assess all the projects that are currently being executed by a given organization. So it has got different verticals, it has got different service lines, and finally the last node is the different projects that are being executed. And what you see here are visual alerts. So the moment you start seeing something blinking red, you know that these projects have a schedule problem. Right? They're going already on schedule. So the moment it is visual, you also know which specific vertical or which specific group of projects have a problem. So this is a visual way in which one can immediately alert the portfolio manager. He needs to concentrate on these specific projects. And these are predictive in nature as well, meaning that we have built a predictive algorithm which looks at the historical trends of these projects, and from there tries to address how these KPIs will evolve in 1 week's time. So in essence, the screen tells you that there are 3 projects which are going to lag on schedule in the next 1 week, right? So that is the use case that we have tried to solve using AI and prediction. All right. Now that we have talked about tracking and monitoring and how we have thought about a case scenario of using visual alerts and prediction, the next big thing is status report. Now, status reporting, the case scenario is this, that the portfolio manager wants to know the main reasons why he's noticing a potential schedule slippage in a specific project. So it so happens that a portfolio manager is dealing with a large number of projects, right? And there's one particular project in his portfolio that is lagging because of schedule. He wants to understand what are the reasons why this is happening, right? So, or why it can potentially lag if you're dealing with predictive systems. So the answer to that is that the AI system that is doing the prediction and giving you the reasons why something is going to lag is that we need to aim for clarity. It needs to tell you why it has come to that specific conclusion about why the project will have a schedule delay. And second thing is scalability. That is, it should be able to come down to the task level, right? And be able to tell you which specific task is the reason why this schedule delay will occur, right? When you're reporting within an organization, model told me so will not work. Meaning, one can never blame the AI for having given you the results. The AI should be able to tell you why the project is going to get delayed. What are the factors that are causing this particular project to get delayed? And what we have noticed, on the other hand, is that typically what happens is execution metrics and financial metrics are analyzed in different silos due to various reasons. So most of this analytics is conducted in silos, but strategy, which is the highest form of deciding where this organization will move, is rarely siloed because you need to look at all parameters in order to come to a conclusion. So because of this restriction that your analytics is siloed, that it doesn't talk to all the reporting systems within the organization, but strategy needs all this data. So what they do is they have different dashboards, and this data is then finally pumped into Excel sheets, and that's why most of your strategy is data within Excel sheets, right? So to solve this problem, we wanted to deal with AI applications that need to be scalable. So the first necessity is it needs to be scalable. That is, it should be able to go to the transactional level of project execution. So day-to-day tasks. It has to be horizontally scalable as well. So we cannot just look at execution metrics or just at the tasks, but we need to look at how well is the team working together. We need to look at the human resource aspect of things. We need to look at the financial aspect of things. Are you within budget, right? What is the SLA adherence at? So a lot of these parameters need to be horizontally scalable. So the data set that you're dealing with is at transactional level, that is right down to everyday execution, and you're also dealing with multiple parameters or horizontal scaling as well. Second, AI applications have to be clear. That means not only do they need to come to a conclusion, but the AI system has to tell the human or report why it has come to a specific conclusion. So the mechanism or the methodology with which it has arrived. So clarity is of importance when we are dealing with AI systems as well. And we have paid special focus to this. So in order to achieve clarity, we use this system of tools called explainable AI, where the model or the prediction model is not a black box, or the reporting that you're doing is not a black box. We are able to give in situ contextual analytics to tell you why the model behaved the way it did. And therefore, the project manager is never at the mercy of the AI, but rather he's in complete control of what he knows within the system. So therefore, his trust in the system improves, his or her, sorry. And lastly, use scaling technology. So because we are dealing with large volumes of data right down to the task level, granular timesheet data as well, we have to deal with a tech stack which allows you to scale in that fashion. So it could be SDFC, it could be Kafka, which talks about routing build characteristics into your model using Jenkins and Spark as well. So this is how we have attempted to solve this problem. And here in this example is an example of how the prediction algorithm is able to explain the methodology with which it has come to a prediction. So in this case scenario, we're looking at a specific project. In that project, there are 3 KPIs: revenue, cost, and schedule. So it is able to manage and tell you how these KPIs will evolve simultaneously over time, right? It's able to tell you that out of a budget of 100%, cost will be 19% over budget, right? schedule will be 11%. So there'll be a 7-day delay, which is 11% decrease. And it's also able to tell you how it has arrived at that calculation. So it give you working notes. So when in doubt, it will tell you, okay, this is the mechanism. So this is an example of how we are using explainable AI to bring clarity to the system. And this entire system is built on Spark, so it's fairly scalable as well. All right, so that's about case scenario and status reporting and how we have used AI to automate that specific case scenario. Next, we come to risk identification and assessment. So here is a case scenario again. So can you tell me how my portfolio of projects will be affected if the average sign-off time of customers increases by 10% due to COVID-19? So the idea here is that risks keep changing over a period of time. Risks are never static. And therefore, their participation in KPI evolution, that is when you're trying to predict how KPIs evolve, or when you're trying to imagine how the project will evolve over a period of time, the risk can never be static. They need to be included in all your assessments. So why is that? Because models by definition are a subset of the real world, meaning that any kind of AI model that we can develop in the future is based on a subset of features. It is not aware of everything that happens. And this is an inherent shortcoming of all AI systems, right? So that is where a human in the loop comes into picture, because the human is able to tell models uh, additional information that models can then in turn imbibe and then change their predictions based on the real world information or extra information that they now have access to. So to reiterate, the probability of risk keeps changing over time. So the risk identification or assessment matrix cannot be static, and it affects on KPIs will not be static either, right? So one should be able to assess different ways in which these projects evolve due to real world case scenarios. And because these are probability based, risks are mostly probability based, we will be able to create multiple case scenarios which can then be analyzed, and a decision can be made as to how to take action for a given project. So risks affect different performance indicators in different fashion. So to add complexity to it, each risk will affect different KPIs in different manner. So you rarely look at one KPI at a time. So these risks should, so when we are doing predictive models or when you're building the AI system, one has to take care that each risk and how it engages or affects different KPIs is taken into account before we make this prediction. And we foresee that the true human in the loop system will be able to combine the predictive power of AI and the situational awareness of humans. So the manager on the ground knows best, right? So he's aware of information that the model is not aware of, and therefore he should have a mechanism by which he can interact with the model and see how it is able to evolve different case scenario, and this thereby bring an agility to project management as well. So here is an example of how we imagine uh, this case scenario analysis takes place. So in this case, we are looking at a specific project, in this case 351129, and we are looking at three factors that affect schedule, effort, and cost simultaneously, right? So in this case, he's looking at delayed sign-off time. So what happens if I increase my delayed sign-off time by 10% or 15%, and then see how these schedule, effort, or cost will evolve over time in the coming few weeks, and from there get an assessment of which path or action should we take for that specific project. So this is what we call what if analysis. The actual set of algorithms that are going on behind is called constraint optimization. And eventually what you do is you run multiple such simulations, so around 200 such simulations, and you get a band which says that based on these real world case scenarios, there's a probability or 50% probability that these KPIs will evolve in this fashion, which you see here. So that is one of the features that we have worked upon and we're trying to showcase. All right. And last but not the least, let's talk about planning and estimation. Now, the case scenario that we can talk about is, let's say we're starting a new life sciences project. So can you estimate the complexity, the manpower needed, and the cost associated with it, right? So planning and estimation is a notoriously tough thing to do. People get it wrong. And as one of our customers said, that your project in general will cost you twice as much as the original budget and usually takes 3 times longer than expected. And that customer will remain unnamed. So why is that? Why do we face such problem? Because a lot of people have a lot of experience. Portfolio managers and project managers usually have a lot of experience. So even then, we either tend to underestimate the budgets or underestimate the schedules that go into these projects. So the key idea that we identified here, where an AI system can potentially help, is if it's able to look at all the projects that were ever conducted within the organization, right? So let's say that we take all the projects that were ever conducted and we look at them across multiple parameters. That is, what was the budget? What was their budget? How many people worked on it? What were the task complexity of that specific project? What were the margins? How was it built? Even we can go to how often have those teams who have worked on that specific project worked together earlier. So all these different aspects we can take into consideration and start comparing them, right? If we had a system which could do this and then give a manager the ability to say upfront that a project, let's say of 6 months duration or 8 months duration, working on technologies A, B, and C, having 3 people or a 4-member team would take us this much time, right? So in order to do this, we come into a field of science called topological data analysis, where we are able to essentially compare all the projects that you have done across 150 parameters and then identify the set of projects that one could learn off of. How does this help? After the project is over, right? I mean, we've asked the question of many people, how often do you look back at projects that were executed earlier? What went right, what went well, right? So 1 year or say 6 months after the project is over, the answer is rarely. Rarely do people look at all the projects that they have conducted earlier, right? This is how we have done it. So in this case, what we're looking at a specific project, and we want to estimate what are the different characteristics of this particular project, how much time did it take, and so on and so forth. So in this case, every single point that you see on the screen is a project that was conducted by the organization, and there's a structure to it, right? And it is dynamically able to compare that project with all the projects that were ever conducted and then forms a cluster. So in this case, there are 6 projects that it has identified that are similar to this project, right? And then it is able to tell you why they are similar. So not only are we looking at 150 parameters, not only are we looking at cost, schedule, the projection, the execution methodology, whether it was agile or whether it was waterfall. We're looking at what is a budget. We're looking at week as well. So what was the week on which the comparison took place? So using all these parameters, we have made the projection, and it's able to visually tell you these are the projects that you need to refer to. And then subsequent to that, we can download the project plans for these projects and then develop our estimations for the new project that we have planned, right? So this is one case scenario of how we are using AI in order to automate estimation and planning for projects. All right. In conclusion, now I think we have come to the top of the hour, half an hour. We have looked at how successful project execution know-how can be leveraged by everyone in the organization, as we've seen in the previous case scenario. We have been able to figure out how projects can evolve uh, across KPIs. So it's about not continuous monitoring anymore, but it's about continuous monitoring along with predictive power. So you're trying to a priori figure out how these KPIs will evolve, not just continuous monitoring. We looked at how we can give enough room for managers, enough time room for managers to bring things under control. So if we are able to identify what are the problems that are plaguing specific projects, we're able to tell them what actions they can take in order to bring the project back under control, and then give them an sufficient time. Like you give a 1 week heads up or a 2 weeks heads up, so that the project can recover. Then they can be more effective. And lastly, we've talked about clarity. That is how we can use XAI to improve status reporting, because that is one thing that is going to be very important going forward as well. All right. One last question. I think before we get into Q&A, I think that brings me to the conclusion of this particular webinar. Before we get into the questions and collate all the questions that have been asked during the webinar, I would ask Nishant to essentially open up the polls for one last question. Nishant?
Okay. Yeah. So if you could just answer this one last question for us. So see, our product that Ashwin just demoed, it evolves with every customer that joins us, right? It's a living, breathing AI system. So while registering for this webinar, many of you said that you were unsure about working, with us on this tool. So I asked the question again. Feel free to answer. And meanwhile, if you have any questions for us about the company, about the tool, please do put it in the comments box, and we'll take them up. Okay, so thanks for your response, folks. I will be closing the poll now. You seem to have bamboozled the crowd, Ashwin. No questions right now. We do have a couple that came in prior to the webinar when they were registering for it, but I think we've covered it. There were questions on AI at scale, right? And how valid would it be for the current day program manager or project manager, given the systems that everyone's using right now? So if you want to take.
Yeah, so so the main idea behind AI at scale is this, that often when we are dealing with transaction-based systems, so there's a strong tendency within AI and reporting systems to basically aggregate. So if you're looking at timesheets or if you're looking at story points, there's a tendency that we'll aggregate the data, we'll take it over the next state of reporting. Then they will be aggregated across different verticals, and then they take it to the next state of reporting. So finally, when it does come to the strategy board, or when people are looking at how effective these various projects are, one can no longer drill down to the base level transaction that caused that delay. So if I want to say across my board, I've seen scheduled delays in my projects, say, right? And I want to figure out if there's any commonality between various projects and the tasks that are involved within them to figure out what is causing that delay, right? So in that, one needs to essentially have a system that can go right down to the transaction level and come up with an answer. So, and in order to do that, you need a scalable machine learning architecture in order to achieve that. And that is achieved through various systems like Spark and say Kafka and all such AI system, scalable systems. Of course, there are other issues involved in terms of data security as well. and they can be dealt with, because when you're dealing with strategy, of course, they have access to all the data. So sufficient privacy gates need to be put in place for such systems as well.
Okay, great. So we have a couple of questions. Sandeep asks, so for the system that you just demoed, what different kinds of project data did you use to model this?
That's great. That's a good question. So the way we have, at least the way we are developing this particular product or developed it so far, we are trying to ingest all kinds of data that we can get our hands on. So in this specific case, we are looking at the timesheet data, that is the timesheets that have been filled by various developers within the organization. We're looking at the quality data, that is what are the bugs that have been filed. We're looking at build data, that is when you have different builds and Jenkins, which builds went through, which builds failed, so on and so forth, very specific to IT. We're looking at SLA adherence. That is, if this is a services project, all the SLA adherence data is also included in this. Then we're looking at the billing cycles, that whether this is a fixed billing, that is, it's a fixed billing, meaning it goes in cadence of milestones, few milestones that you have defined, or whether it is a services project, so kind of project that you have, the kind of execution methodology, whether it is agile, waterfall, so on and so forth. So we've basically taken all this data and merged them into one single repository. That being said, right now we are in the process of getting our hands on other types of data that could be potentially added to the data set as well. So we're looking at how we can use natural language processing in order to process the conversations that people have and add that to talk about the sentiment of the team that is working on that specific project as well. So yeah, I hope that answers the question.
Pratik asks, Ashwin, so I mean, I'm guessing everyone who joined in today, uses existing systems, right, that have been in place for quite some years. Is there a way to upload existing project data to a system?
Yes. So at this juncture, as I had spoken of earlier, the entire product is built on Spark, right? And what we do is that the code and Spark itself can connect to a large number of databases. So you can connect to RDBMS databases, you can connect to NoSQL databases, so on and so forth. So typical way in which we deal with is that if you're an existing Swift Enterprise customer, we can, with the customer's permission, we directly can pull that data into our platform. And of course, we can explore other mechanisms as well. It could be simple CSV uploads as well, but yeah, we can explore that.
So we have 1 minute left of the 45 that we said we'd take of all of you. So folks, if there are any more questions, you have our contact details on the screen there. Feel free to reach out with any sort of questions. We will also get back to you. And one last thing, Ashwin, if you want to pick it up, Nikita asks, any chance we can track productivity data, quality data, and responsiveness data?
Yes, yes. So the short answer is yes. Quality data is a part of what we are modeling in terms of if let's say that this is a phase gate project, that is its standard waterfall kind of project. So we can look at in which particular phase did this particular defect evolve, or when was it noticed, when was it caught. In case of the same thing in terms of agile systems, that when did this bug, which sprint did this bug occur in, right? So we look at quality data as well. And yeah, the short answer is yes.
Okay, thank you. Thanks, folks. Thanks for joining us today. We hope you found the session useful. Like Ashwin mentioned, we will be back with a couple more webinars, dealing with a lot of other things that we haven't yet shared with you yet. Any final words for today, Ashwin?
Thank you very much for attending the session. The platform that we are working on, we are very positive about it. We want to expand it across verticals. So at this juncture, you would have noticed it's mostly IT centric, but we believe it is scalable across verticals. So it would be great to have a follow-up conversation on this with all those who are interested. Thank you for joining us today, and we hope to see you again.
Thanks, folks. That's all we have for today. We will be in touch. Thank you so much. Thanks once again, Ashwin.
Thank you, Nishant. Thanks, Mahesh. Thanks, everyone. Bye-bye.